Hello, let's solve some Leetcode today. Okay, we have unique character of occurrences, unique number of occurrences. Given an array of integer, I return true if the number of occurrences of each value array is unique or false otherwise. So we calculate its so solution will be very simple. We calculate number of occurrences, then we put it through the set, and if set and our number of occurrences hash table has the same amount, means unique, right? And that's it. So to quickly put it, I would do following. I will create counter of array and return C len of counter equal len of set of counter values, right? Occurrences has two unique. Oh, okay, so it's different. And so then I have to collect all occurrences somehow, like values. I don't know. I have to check, but then I will return that len of C equal len of set of C. I don't think it's if it's values, it could be different. Oh, it's values. Okay. Yeah, submit. 100%. Okay, given two strings ransom note and magazine, return true if ransom note can be constructed by using letters from the magazine, or and false otherwise. Yeah, so it's very simple. We count. We create node counter from ransom node, right? Again, counter again, ransom node, counter from magazine, and we return ransom node equal magazine. AB return false, magazine. Oh, okay. So it, yeah, so magazine could have more. So we have to make sure that I can say that length of a node equal length of intersection node and magazine. Still no. Y, okay, A, and B. Length of node will be two, length one. Length of node and oh, same amount. Okay. Then let's go following for each entry, for each key value in ransom node. What we can do, we can if magazine key equal value, not equal value, we return false. So we will go through every occurrences of a letter in a node, and we check that these occurrences, if magazine, it could be more. So I can say if less, if magazine has less letters than we need, right? I think it's items, and I don't know why it's not unpacking, but we can say that values must be sufficient enough. So more or magazines, letters in magazines must be more or equal value. Meaning, so if value is more than we have in magazine, we return false. So we can, letters in a node are more than letters in magazine, and we return false. Otherwise, we return true. Simple enough. Maximum number of balloons for like given a string test, you want to use a character of text for as many instances of our balloon as possible. You can use the text each character at most once. Okay, return the maximum number of instances can be formed. So what we can do, we can create counter from balloon. In this case, we will know how many different letters we have. Then for every key value in balloon, and then we create the same counter for text. It's similar to note, ransom note that we have. However, we need to have a counter here. So we can do following. If then we go through the letters in text in balloon, right? And we subtract from the text. And so we can say like this: if text, let's say letter, right? Letter, text, letter, more or equal So yeah, let's write English first. How is the solution gonna be? We have to somehow iterate through like while. We can do while, and while we're constructing words balloon, right? Balloon, 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 balloon. So, or we can calculate amount of balloons, letters. For example, and do it in one set, in one pass. So what will be the best way to do it? So, for example, we can iterate through the balloon, or we can iterate through the counter text. Or we can say while text. meaning we're gonna delete zero values. So what we're gonna do, we're gonna for every letter in balloon, if amount of these letters in text more than amount of this letter in balloon, we gonna decrease by this amount of letters. And if amount of letters becomes 0, we break. Otherwise, if we break immediately, meaning we found inconsistency. And here at the end we return count. Not inconsistency, but inefficient amount of letters. Then for every at the end, here we increase count, meaning we subtracted one balloon word, then we go another and get another, and so on. So this is the one way to do it. Not enough values to unpack. Expected 2 got 1. Okay, I got k value. Okay, I'll do items. Let's write items. Okay, so while we have, because we must be, we are not breaking, we removing. We say delete L from T. Oh, how delete? How deletions from deletion of element from map. I think it's del, but I don't remember. Let me take a look. Yeah, so it's del, then map, like this. And we are not breaking, we can continue. We're gonna be timeout again. Yep. So if more than or equal amount of we subtract, we do it, and then we move further. Cycle break. Here is break if we have found that amount of letters here more than we have in text, right? Oh, we are breaking from, not from here. Yeah. So let's return. Yeah, I see what the problem is. We are breaking from this cycle, but still from in this cycle. This is why we have to return. Kind of nice. Not gonna be fastest. 6%. because this is a simulation way, like simulation pattern to solve it. We going through text and we calculated amount, but we have to find minimum for every letter in this. So if we take a look here, see like minimum count B, count C divided by 2. And this is like entire calculation. So 1, 1, 1, 1, and we take minimum from that. From that numbers, and that numbers will be amount of. Yeah, let's do this. So yeah, it's pretty understandable why this code is working. So we have like, for example, if you have a 2B, that means we think then we construct 2 words, right, balloon. But what if we have just one N? We're not gonna construct 2 words. We're gonna construct one because N is 1, and this is why we take minimum from all of these words. Yeah, and if it's 0, means we cannot construct at all. So yeah, if it returns 0. Yeah, should I write it? No, it's fine, I guess. Because this is brute force solution, and yeah, let's rewrite it. But I like this brute force. So we return B. So if we have a text of B character and text of A character, text of L divided by 2. This, right? Oh, we need, I guess, the same text of O divided by 2 and text of N, and that's it. T is not defined. Yeah, we have to calculate counter from text, so we keep this. Yep, 63. Oh yeah, it's probably because of this guy. Doing this and see the magic happening. No, 22 is actually slower. Nah, that's fine. One last time. 73. It's fine. Okay, next one is move zeros. Let me see this one. Solution really quick. I want to preserve mine. I don't know. I was like kind of enjoying doing it. And just for my own records, it's like straightforward and now it's very close to my heart because it's straightforward. And yeah. Yeah, but this is more. I agree. This is much cooler. So we calculate how many records we need, and we take minimum from that for every record. Yeah, I like it. Cool. Next one, move zero. Given an integer array nums, move all zeros to the end of it while maintains the relative order of non-zero element. You must do it in place. All right, so it's probably swapping game. So we have our solution will be, we will have a 2 pointers, or we will iterate left and right, have 2 pointers, left and right, and what we're gonna do, we're gonna point at first element, gonna point left, gonna point on first element, and the right gonna point on second element, and if left is 0, we swap. If left is 0, we swap. If left is 0, we swap elements. Then what we're gonna do after swapping? So we have 1, 0, and we move left and right forward. Then if left is 0, we swap, we move left and right forward. If left is more than 0, we swap. So since this is a problem, we cannot swap if not 0, if it's not 0, right? We still move forward, but we are not swapping if both are 0. If both are 0, we are not swapping. And then here we swap. 0, and we move. And here we swap. And we move, we reach the end of the array, and we return. Okay, so let's do this. So if we can assign left and right 0, 1, and we can calculate length of the array as len of nums. Then we can iterate for right. Yeah, we don't have to. We just have to assign left, because we are iterating right every time for right in range, starting from 1 and ending to L. What we wanna say, if nums left equals 0 and nums right not equal 0, we swap nums left, nums right, nums right and left. And then after swapping, we increase left. That's it. Let's see. Yep. Perfecto. Wrong answer. Okay, we're missing one. One sort of operation. I guess. No? Use this case 27. So, okay, let's run this example. So we assign left here, we assign right here. Left is 0, no. Right, we move right forward. So if left is not 0, we are moving left. Okay, so I can say I'll leave so if left equals 0, then we move left. Oh, if left not equals 0, I mean, sorry. Yep, perfect. 89%. I really like it. Yeah, I think I had it on mock interview. Had this task. It's really good. Very good for mock. Because it's look like it's easy task. However, it requires like focus and concentration and not to lose like and debugging, and requires to debug it in on different examples in order to figure out how it should work. Yeah, it's very good. Okay, let's see. I it's 89%. It's pretty good. Um, can I see who made it faster? Anybody? Okay. We want to modify the place instead. Oh, so there is a yeah. If length none less than 1, just return. Hey, it's not in place. Uh, no, wrong. Okay, let's move to another one. Average waiting time. The restaurant, did I saw it? There is a restaurant with a single chef. You're given an array of customers when customer arrival and time. Arrival and time. And arrival time is sorted for non-decreasing order. Time is the time needed to prepare order for each customer. Okay, so non-decreasing, which is good. So we are getting customers in a way they arrived to our like 1, 2, 2, 5, 4, 6. It's similar to, there is a single processor task also. It's very similar, like we have single processor that process task. And when the customer arrives, he gives the chief his order, and the chief starts preparing once he, start preparing it once he idle. The customer waits till the chief finish preparation order. The chief does not prepare food for more than one customer at a time. In order the given input, returns the average waiting time for all customer actual answer considered from the actual answers. Solutions with the okay. So it's still simulation. Or maybe I'm just thinking in simulation patterns all the time. But what we can do, we can so consider this example. This input. As the first customer arrive at time 1, and then we are waiting until his order is prepared. Right? So this customer waits 2. This customer waits second customer. So first customer waits 2, right? First customer waits 2. Then second customer has to wait until this is prepared, plus his time. So 1 plus 2 plus 5 equal 8. Second customer waits 8. No, it waits 6. Why minus 2? Oh, he arrived at 2. Exactly, minus 2. Yeah, because he is not arrived here when first customer. He arrived at 2. He arrived here. So it equals 6. And third customer waits for total preparation time for his is 8 plus 4, which is 12. But he arrives at 4, which is 8. Right? 2, 6, 8. Why 11? 11. Why? So we have he arrives at 4. He has to the chief takes his order and starts preparing at the time 8 and finished in time 11. Okay. Yes. So 8 plus this is arriving time. I have to add 8 plus this time, right? I mean this time. 8 plus 3 minus 4, which is 7. And total will be 2 plus 6 plus 7, which is it divided by 3. Okay, so let's we have to iterate, right? I don't know condition yet, but we have to iterate, and we have to have before every customer we have to have a chief ready time when he is available. So let's call it ready time. He is ready immediately. And we iterate to the customers with arrival and time. In customers, right? So what we're gonna do, we gonna say if ready time more than arrival time, we have to calculate like wait time for this customer. And we can say that wait time for this customer will be arrival minus ready time plus and then we have to calculate like overall time, overall waiting time, like let's call it all time. So we add all time to we add all time plus waiting time. At the end we return all time divided by length of customers. That's it. So yeah, let's run through our examples, first example, and see if it will work. So we have ready time 0, all time 0. We take a equal 1, t equal 2. We assign waiting time t, which is 2. And here we add all time will be 2 plus 1. Two plus 2 is 4. Okay. Okay, so it's not correct. All time equal to, but it shouldn't be 2. Okay, so this is arrival time and this is preparing time. Let's call it AT and PT. So if ready time is more than arrival time, we add additional time so if chief will be ready after some time into arrival, we add this difference to a waiting time. Then overall time will be we just add waiting time to overall, but we have to add cooking time here, preparing time. We are not processing preparing time. So we just add preparing. We add difference between our preparing time minus arrival time. In this case, we have 1. Our time will be equal, waiting time will be equal to minus 1, which is plus, which is 3, right? Because 2 on the top, 1 on the bottom will be 3, all the time will be 3. Then we go to seconds. Do we have to update ready time? I think we should, because in this case, our cook chief will be ready at waiting time. Okay. Yeah, I have this. So this is arrival time. I have this urge to test it on a test case and see. Okay, so it's 3 only. It's 2.5. Okay, why it's only 3 but not 5? Let's print all time. Which is 9. We missed something. Okay, then we run through the one. Okay, one, we have all time 3. Now let's go to second one. We have 2 and 5. And we have ready time equal to 3. So chief will be ready at 3 only. So first we assign work time 2, but then because our ready time is 3, it's more than arrival time by 2. We already add arrival time minus ready time, which is, oh, I see the problem. So we're extracting instead of adding, we should 11. Okay, it's better, but still not enough. 11, which is not 13, right? I feel like at the end, okay, so we add waiting time become 3. Now preparing time will be 5, so it becomes 8. So 8. So the waiting time of second customer. Oh, there is a thing, interesting thing. 8 minus 2 Wait a second. I feel like I have to print this in, so I will know exactly how my calculation is going for that. 254, 2, 6, 7. Two, 5. Okay. Previous time. It's only 5 because it's plus 5 minus 2, which is 3. Plus 3 should be 6. Why it's giving me 5? Question. Because I have to do arrival time plus. Yes. Yeah, because I have to add arrival time. Yep, 6%. Okay, let's remove prints. Prints here, prints here. 55. Yeah, I guess it's okay. Let's see how other people solve it. So arrival order, yes. If arrival more than current time, we also current time is equal arrival. Current time plus order result. Current time minus. Oh, it's so simple. I like it. This is amazing work. Yeah, it's like it's worth to analyze it deeper and reduce this reduce amount of intermediate variables and calculations if we can. But yeah, I didn't do it, so my code is a little more convoluted and complicated. But yeah, we did a good job today. Thank you for watching and see you next time. Bye.